Hello, hello. Welcome one, welcome all to another installment of the LeetCode weekly roundup where we look at some of the questions that we were unable to solve within the last week of us doing our LeetCode practice, and we try to solve them again during our Sunday. A couple things that I'm going to be changing. So if you are a longtime viewer, if you've been with me since the first day I started posting back in July of this year, July 16th, you know that I was doing weekly roundups every Saturday. I'm trying something new today, and it's almost because of yesterday was my girlfriend's birthday, so I just didn't actually do the roundup yesterday, and it kind of worked out in the sense that I'm doing it today, and now that I'm doing it today, I feel like maybe Sundays are actually a better day to do the weekly roundup since it sort of marks the end of the week anyway. So moving forward, I'll probably do weekly roundups on Sunday. And also moving forward, one thing that I want to do is I am thinking of keeping weekend streams to 30 minutes and the weekday streams to an hour. Reason I'm doing that is because on the weekends, of course, a lot of us have a little bit more limited time in the sense that perhaps we want to go out, we want to have fun, you want to, enjoy your weekend. Maybe you want to spend time with family or your loved ones, right? And so I think that on the weekdays, a lot of us are sort of primed to work, right? We're already in the mindset of, well, it's the weekday, I'm going to work hard. On the weekends, you want to take a little bit of a break. So I think because of that, I'll be making weekend streams from now on a little bit shorter. I'll be keeping the weekday streams at an hour length. That way we can, again, continue on our journey. And it'll give you some more time on the weekends to really focus and, again, spend time with your family or do anything else that you want to do that's fun. So with that being said, let's go ahead and get started today. And of course, let me go ahead and open up my YouTube analytics because always want to make sure, that's one thing that I really need to start doing before the stream starts. I just want to make sure that we have everything looking as it should. Let me see, it looks like we have an excellent connection. Always like seeing the green there. That's always very nice. So with that being said, let's go ahead and get started. So the way I like to start these weekly roundups is I just start by acceptance. We look at all the questions from question 0, we go all the way down, and the first one that's not done is where we start. I always start the same way, and so that's what we're doing today. So I'm just going through page 1. It looks like so far we're still done with everything on page 1, so that's very cool. Let's go ahead and move to page 2. Scroll all the way to the top here. Let's see, which one is it going to be? All right, looks like we have one right here, baseball game. So weekly roundup doesn't necessarily mean, I don't quite remember this one yet. Maybe I will as I start going through it. Actually, no, I think I do remember this one. But a lot of times there might be new questions that we just never saw at the time that we were in this range of questions. Because, there's new questions being added to LeetCode all the time. Or sometimes it might just be questions that we never solved prior. So let's start with this one. So we're keeping score for a baseball game with strange rules. The game consists of several rounds, where the scores of past rounds may affect future rounds' scores. And before I go anywhere else, let me make sure. Let's see. We do got output, right? Okay, cool. Sorry if you heard any double audio there for a second, but all right, several rounds of scores. At the beginning of the game, you start with an empty record. You are given a list of strings operations where operations at the ith index is the ith operation you must apply to the record and is one of the following. An integer x, record a new score of x, plus record a new score that is the sum of the previous two scores. It is guaranteed that there will always be two previous scores. D, record a new score that is double the previous score. It is guaranteed that there will always be a previous score. And C, invalidate the previous score, removing it from the record. It is guaranteed there will always be a previous score. So it looks like a lot of these is guaranteed, it's guaranteed. All these operations will always be valid. So every single time, what I'm thinking is keeping a stack, or we can sort of use that to calculate this here. Or maybe even not. We might not even need a stack, but let's just go through this example here and figure out what we need. So we're gonna definitely have a variable of points, right? And any one of these different operations, we're going to be calculating new points. So 5, 10, 15. Okay, cool. So if it's an integer x, you record a new score of x. I think what we can do is, okay, we'll say we have 5 because now we're at x, and I'm going to create this I variable up here. Okay, we're at 5. We're going to record 5, and points is 5. We get to 2. We're going to record 2. Points is now 2. We get to C. Let's see. So C is invalidate the previous score, removing it from the record. When we get to a C, what we do is we pop off the previous score. So we pop off 2, and now this becomes 5. When we get to I, removing it from the record, or when we get to D, record a new score that is double the previous score. So we're going to take the previous score, which is 5, and we'll double it, which is 10. So that's 10, and this becomes 15. Now we get to the next one, plus record a new score that is the sum of the previous 2 scores. 5, the sum is 10 and 5, which is 15, and this is 30. So is it 30? Yep, it's 30. I think last time I went over this, I do remember going through this, and I tried to do it a little bit too fast. I think this time we should be a little bit slower. That's always, you know, taking the time to really do this example and drawing things out really, really helps, I promise you. So if you feel like you're stuck on a problem, I think a lot of times people that are generally into software, we just want to jump right into the code because if we're being honest, the coding is the most fun piece. But if we just take a little bit of time in the beginning to plan it out, it can save us more time in the future, and we'll end up understanding the problem that much more. So let's go ahead and go for this sort of method that I just did here, and we'll figure it out. So I want to create a new array. I'm going to call it recorded scores. And recorded scores is going to be this array right here. And then we'll also have our points. So we'll declare our points up here. Points is 0. And now we can say for const op of ops, we have a couple different things, right? We say D plus or C. So I think there's 4 different paths we can go down here. If op is equal to a plus, that's going to be one thing. Else if op is equal to a C, that's going to be something else. Else if op is equal to a D, that'll be its own thing. Else we're just dealing with a single number. So let me try and go through this whole example again, doing the same thing that we just did, right? So when we got to a 5, what is it that we did? The first thing we need to do is if I want to record this, what I should do is I should parse the op, right? So I should say parsed op equals parse int, of op is 10, and 10 is just the radix, meaning base 10 in this case. Parse op, we're going to push this into our recorded scores, but I'll also increment points plus or equals parsed op, and I'll also say recorded scores dot push parsed op. Okay, so if we're just starting from the beginning again, right, let's delete this array, let's reset our points, and we're at the beginning. So I is not a plus, it's not a C, it's not a D, so we're going to parse this to make it a 5. We're going to add it to our points, and we're going to also push it to our recorded scores. Now we go to the next one. Same thing. We're going to parse it, so we'll get 2. We'll add it to points, right? And then we'll get to the next one. Or rather, we'll go ahead and push it to our array. 5 and 2. Now we get to C. So what happens when it's C? When it's C, invalidate and remove the previous score. So here we can say const previous score equals recorded scores at recorded scores dot length minus 1. That'll give us the previous score. And actually, there's even a better way of doing this. Const previous score is just recorded scores dot pop, right? Not only will this give us the result back, it'll also remove this from here. So now we can say points minus equal previous score. Right? So we pop the 2, and now we subtract the 2, so now we're here. Now what happens when we're in D? When we're in D, we're going to do what? Record a new score that is double the previous score. Okay? So again, we'll say, this time we don't want to pop, right? So this time we'll say const previous score is recorded scores at recorded scores dot length minus 1. Here we'll say const doubled score equals previous score times 2. We'll add that to points. Points plus or equals doubled score, and also recorded scores dot push doubled score. Right, so we got to our D. We get the previous score, which is 5. We double it, so now it's 10. We add 10 to points, and we also push 10 to our recorded scores. Now we're at this 10. And now we finally get to the plus, so it's our last one. What happens when it's a plus? Record a new score of X, record a new score that is the sum of the previous two scores. So let's say previous, I guess we can just say, yeah, previous score, or I can say last score is equal to recorded scores dot length minus 1. Oh, that's the last score. I'll say second to last score is recorded scores at recorded scores dot length minus 2. So we're gonna record new score that is the sum of the previous ones. So we'll say const new score equals last score plus second to last score. And now we'll do the same thing. So we'll say points plus or equals new score and recorded scores dot push new score. And at the end, we should just be able to return points. So let's remove this, let's remove this, let's remove that. And I'm just gonna go ahead and run this for both of our test cases, and let's see what we end up with. $30, $27, and 0. Okay, looking good so far. Let's go ahead and submit this. Okay, 18.69. I'm overall very happy about how we approached this question. There's one thing I'm noticing here. Why? Oh, because we're just invalidating the score, right? We don't actually need to push anything for here. There might be some optimization that we can make. I think we can probably get away. We can probably not have to use recorded scores. I think we can figure out a way to maybe maintain. I think if we have two different pointers, like a previous and a current, maybe we can keep track of the scores that way, sort of like keeping, not like a sliding window, because I guess we just need to know if we add an integer x, okay, record a new score of x, that's fine. We can just add it to points. This one will be different. This one, record a new score that is double the previous score and validate the previous score. So maybe we can just maintain a previous and a current. Although for this one, the sum of the previous two scores, I'm wondering if maybe we have like a sliding window that we might be able to use. We can have like A, B, C, and somehow figure out a way to update those variables every single time. We can probably figure that out, but personally, I'm pretty happy with this right here. If we think about the time complexity, so, you know, in terms of time, it's going to be linear because we're just traversing through ops once. All these other operations are going to be constant time. And then as far as space complexity goes, we'll have recorded scores. And recorded scores, like how much does it grow? I mean, I suppose that it could grow to be as large as ops in the worst case perhaps, or maybe not in the worst case, but maybe if these are just all numbers and no other operations, then it will be as big as ops, so it could be O of n. I think that if we figure out a way to do it with our variables, we'll still have a linear time complexity, but we'll save on space complexity. But like I said, I'm pretty happy with this. Let's go ahead and see what the solutions say. So this one right here wants a stack for ants plus or equals score. So here they're doing something similar that I thought, like they use a stack to keep track of all the different, essentially they create recorded scores and then at the end they loop over the stack and do the same thing. But here we're also maintaining points as we go along. Yeah, so I like this. I like this question. I actually think it's pretty good. It looks like I'm curious why the like to dislike ratio is so terrible, but that's okay. I mean, you can expect to find some of those. All right, so that's the first one. Pretty happy about that one. So let's get to this one. Number of recent calls. Ooh, a really, really bad one. Okay, you have a recent counter class. Actually, give me a second. I'm gonna have a drink of water. For anyone out there, make sure you drink your water. Stay hydrated. I'm sorry if my microphone picks up the swallowing of the water. It might not sound very nice in the mic. Okay, you have a recent counter class which counts the number of recent requests within a certain time frame. Implement the recent counter class. Recent counter initializes the counter with 0 recent requests. Int ping int t adds a new request at time t where t represents some time in milliseconds, and returns the number of requests that has happened in the past 3,000 milliseconds, including the new request. Specifically, return the number of requests that have happened in the inclusive range t minus 3,000 and t. It is guaranteed that every call to ping uses a strictly larger value of t than the previous call. Okay, so recent counter ping, 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 ping. Okay, and they're giving us t, which is time. All right, so recent counter, new recent counter ping 1. Range is 1 through, oh, okay, negative 3,000. Okay. Recent counter ping requests 1 and 100. Range is negative 2,900 to 100. So, okay, there's 2. Recent counter ping 3001. Anything from 1 to 3001, including the one itself, 3002. 1 to 3002. Oh, and they don't want, let me see. Oh, so it can't include the previous one, but it could include t. But not, okay. Each test case will call ping with strictly increasing values of t. Okay, I sort of understand what they want here. Now I'm trying to figure out the best way to do it. I almost think like this will be, so they're going to give me t. I can figure out this formula. I'll have to, like, I'm going to have, yeah, like pretty much we're going to be building this array. Every time we call ping, we're going to be adding to the array. And then they just want us to say for a given range, how many numbers fall within that range. I wonder if there's a way, it almost seems like, not like an interval per se, or maybe, I mean, it is an interval, but there's probably a way of doing this really quickly. I think we can just go from, like, probably what we can do is for every iteration, let's say we always have like some array and we always have a range. We can start from, like in this case, if we say we're going from, let's see, recent counter ping range is 2 to 3002. We'll just say what's the first number, like 1 is less than 2, 100 is greater than 2, so we'll stop here. And then over here, what's the first number that is, I guess, less than or equal to? We have 2 pointers and we can just calculate that range. So like 1, 2, 3, 3 minus 1, that's 2 though. So how many numbers are included in that? Yeah, I think that's something that we can do. Not sure of how fast that is, because I also think as we start, let me see, if I add 100, is there a way for me to know where that 100 is? If I add, yeah, let me show you all what I mean here. So let's say we have, this is keeping track of requests. Count the number of, so let's say this dot requests is equal to an empty array. What can we do? Every time we call function t, let's say this requests dot push t const range is equal to what? T minus 3000 and t. Okay, so now we want to find, yeah, how would we 0 to 1 and then that's 2, 0, 1, 2, 3, how many numbers are included in there? Return 3. Do I just always add 1? I'm thinking about how to like get this from 0 to 2. Yeah, I think we can just add 1. So yeah, I think what I'm thinking of doing is, let's see, let's say start equals, or we can say const beginning equals t minus 3000, const end equals t, which I guess we don't really need that one. So I want to find, for let I equals 0, I less than this requests dot length, I plus plus, or what I don't even need a for loop. I can have 2 while loops. Let's say, yeah, let's say let start equals 0, while this dot requests at start is less than beginning. All right, so let's see here. Recent counter ping 1, this request, the range is -299 to 1. So this, if I have 1 here, range, I need to find the first thing. So that's less, so that's fine. But then this would actually go out of bounds, right? While this request start is less than beginning, I need to find the distance of numbers that are in between that range. So why would I stop here and not continue forward? Sort of what I'm thinking for this one. There's something, I have like this gut feeling that's like, oh man, there's definitely a better way of doing this than trying to go through everything. -299 and 1. I guess we also just need to see how many numbers. I mean, we can just go, yeah, wait a second. We can just count all the numbers that are in between. It needs to be greater than t. Let me see. Okay, so in the past, in the inclusive range, t. So it needs to be greater than t because this is 1. Oh no, inclusive. Yeah, I think. Wait a second. I have a better idea. Yeah, for let I. Let's do this. Prototype ping. We push it onto t. We said let request count equals 0 for const request of this requests. For, oh, you know what we can do? We can actually reduce this. We can say return this requests dot reduce. We have an accumulator and a value. We'll start off with 0. So here we can say if value is greater than or equal to t minus 3000 and val is less than or equal to t, then here we can return accumulator plus 1, else we just return accumulator plus 0. I think that might actually be enough. I think this is what they want us to do. The only thing that I'm not in love with is I feel like I'm definitely doing duplicate work. Like I already have, like I can certainly use like a different data structure, I think. 15.87. Map sum pairs, kth largest. Yeah, there's definitely, I just know for sure there's a better data structure for this, but I'm not sure of what it is off the top of my head. To keep track of different intervals, would a prefix sum work? A prefix sum is just going to tell me at what index the sum so far is, but this one I want a range. Yeah, maybe what we can do instead is, because here I'm having to go through the entire array, but here maybe I can just use 2 pointers. Yeah, it needs to be greater than or equal to t minus 3000. So 1 is greater than or equal to that, sure, okay. And then we go out of bounds, but I need for that to stay at 0. This is less than or equal to. -299 is less than or equal to. So how many in this range fit that? Then we add 100. That's a different range. That's like a different interval. Yeah, isn't there like an interval tree or something like this that maybe we can use? I'm very curious. I really want to see the related topics here because this might be design queue and a data stream. Can we just, a queue, push this one in, and then we check, do we just get the size every time? Recent counter ping 100. This is the new range. Oh, but wait, it's always gonna be 3,000 seconds, right? So yeah, I think there's a way that we can pop values off the end as soon as we pass some threshold. Yeah, we always want to keep it within some range. Like 100, 100, 3,000, then 100, 3,001, 3,002. So it's like we have this new sliding window. Why do we not consider? Yeah, I think I can just keep incrementing that window. I think I can keep expanding whatever window we're looking at in here. If I ping 100 and I say, look at the first one, that still fits. Look at the last one, okay, that fits. 3001, we have our range. The first one fits, okay. So we can pop that one off. We can pop it, we can remove it because it doesn't even exist anymore. Or instead of removing it, we can just have, yeah, I think I know what we can do. And I know I used like related topics, so that's maybe kind of cheating, but this is what I'm thinking here. We can have our array, right? So we have 1, and we have the range we have to look at. So we can look at that first number and say, well, that fits. And we can look at the last number and say, okay, that fits. We have 1 and 100. Okay, both of them fit, so we just return the size, right? Then we add a new number, 3001. The last one fits. Okay, cool. I think now what we can do is the next time we come around, 100, 3001, 3002, we look at the first number, it doesn't fit, so we can increase this pointer. Yeah, I think we can do this. We can increase this pointer, and then we always just return end minus whatever that pointer is. So let's do this instead. Let me put this over here. Come back to here. This time I'm going to keep, let's see, this. Let's just say this start equals 0. All right, we're going to push t, and now once we have push t, we can compare the ranges. We can say, so if this requests at 0 is greater than or equal to t minus 3,000, what can I, well, I don't need to do anything there, right? If it's less than 3, let me see, because in this last one, 100, 2, it's less. Okay, so here, if it's less, we need to do this dot start plus plus. Okay, and then when we add the new one, I guess the new one will always fit, right? I think the new one will always fit. So what if we just return this dot requests dot length minus this dot start? Am I making too crazy of an assumption to think that the last one will always fit in the range? I might be, but I want to try this out. Because like the most recent ping will always fit. We just need to see how many in the past don't. But I guess this can always be, what's the new one? Add a new request at time t where t represents some time in milliseconds. And t can be each tasking with strictly increasing. I think t can probably be anything, so I shouldn't just assume this. Maybe here I should say while this requests at this dot start is less than t minus 3,000, increase it. And then we can just remove it. So let me do that again. Okay, let's run this. Oh, wow. I mean, look at this. A significant improvement in performance here, right? So last time what we were doing was we were constantly going through the entirety of our array, always counting the ones that fit in that range. So for each one of these operations, like if we have n ping operations, we're going to have to go through like all the different requests. So it'll be like P times R, where P is the amount of ping operations and R is the amount of requests we have. And here though, this is just I mean, this could potentially be constant time depending on if this ever happens, but still this loop will certainly happen less than n times. So now we're only keeping track of a window. We just need to care, and I think the most important piece is this. Each test case will call ping with strictly increasing values. So I think that paired with the fact that the most recent ping will be included, right? Because t will be included, right? We always know that we can count the last one. We just need to see how many previous ones we can count. And we can always keep track of the previous ones by keeping this start pointer. So even though this question is marked really poorly, I really like the way that we approached it. And I hope that if you're watching this, you learned a little bit just by me seeing how, you know, I tried with that first reduce method, and then we just kept track of this. I think this is very nice. I feel like this is an important concept to know. The queue is really cool. Nice. Let's see if maybe we can do one more. I think this one, yeah, this one's crazy. I really don't think this is an easy question, but I had drawn this one out a while ago, and I think it came out to be something like, let me see, 1, 2, 3. Yeah, I think we can just keep moving. In one step, we can change the position of the ith chip from I plus 2 or I minus 2 or plus 1 and minus 1. So I think here, if we have 1, 2, 3, if we draw this out here, right? Let's say we have this, and then we have our 1. We copy that. We have our 2 and 3. So let's say 1, 2. Oh, doesn't want me to draw in here. Oh, did I just make this like one huge? It doesn't like that I'm trying to like type in here. Maybe I'll just type way over here. Okay, 3. Okay, there you go. Let's just keep it like that. Now let's draw our chips. And I'll give these a background. Right, so here we have 2 of these. And I really should move all this lower. Right, and then we have 2 over here. We have 3 of those and then 2 over here. I think what we should do is, if we want to minimize the cost, I feel like we should do as many of the -2 operations that we can. But here, in this case, we can't. So I think what we can do, how many? Yeah, so like here we just move 1. Well, I guess 1 and 2. That would just be 2, right? If we have this one, how is this one? This is 1, 1, 1. Let me delete these. So I could move 2 and then 1. That's also, oh wait. Oh, because the 2 operation is 0, right? We can say move any of these 2 to this one and then 1 over here. So we should probably always try and see how many operations of movement 2 we can do and then go to 1. Now, it's tough because how do we move the chip at position 3 to position 1? At any point, how do we know to like where to move it? If I have an array like position length, but the position at I can be a large number. So maybe we just need to check like, I don't think we need to necessarily keep track of, like, can we be greedy with this? How many times would I have to go through this? I almost feel like, what if I go through this once and I say, well, is there a position I can move to my right that is 2? Maybe here I can say, okay, move that one 2, and then just go through the entire array and then start again and say, okay, can I move 2? No, but I could move 1. Okay. Maybe we can do that and just always move chips to the right. But will that necessarily reduce my cost? I'm not sure. Move the chip at position 2 to position 1. We need to move all the chips to the same position. In one step, we can change the position of the ith chip from position I to, right? I think here, I mean, cost 1 to move 1 chip. Okay. Cost 2. Oh, and it's not even just, Yeah, we gotta move all those chips to 1. There's probably, this might be like dynamic. This might be dynamic programming. Now that I'm thinking about it, this might be dynamic programming. If I start here, if I start like at the end, and I say I can move, like, why would I move chips two back? I mean, that'll be cost. Well, I guess I can move these here, but then this will be 1, 1, 1, and that's 3. So I don't want that. I want the smaller cost. Right? Because it's weird. Because at this step, if I can say like the length of this, move it over, that's 0. That's going to be 2, or moving it here, that would give me 3, or that would give me 0, but then when I come here, I get 3. So how would I know at which position? Yeah, I don't think this one I can probably solve in the small time frame that I want to for weekly roundups. I really think this one is going to take a lot more effort. And I feel like if I come here, okay, array math and greedy. So maybe it's okay to just do greedy, but again, do I just always move it to whatever position's available? Like if there's a 1, I move it to the 1. If not, I just move it 2 left. So there's a 1, I move it 1. Okay, cool. And then I'm done. Okay, if we do 2 here and then 3. No, rather if we go here, let's remove these here. I say, okay, there's a 1, do 1. Now we have 2. Okay, just put them in the next one. Do I just try to keep moving them all the way, but onto what? And why would I stop moving it at any point? Like if I move all these here and then I get here, like imagine I had my 3 here. Like if 1 to the left is empty, do I just say, oh, just move these here? Like how would I know when to stop? Yeah, I think this will take a little bit more. Maybe I might even dedicate a stream like towards the end of this whole journey with all the easy questions. I plan on having probably like a 4-hour stream where we just finish all the last ones that we couldn't. And perhaps I'll save it for then. Any other ones that maybe we can do? Let's see this one. Special typewriter with lowercase English letters A to Z arranged in a circle with a pointer. A character can only be typed if the pointer is pointing to that character. The pointer is initially pointing to A. Each second you may perform one of the following operations. Move the pointer 1 character counterclockwise or clockwise. Tap the character the pointer is currently on. Given a string word, return the minimum number of seconds to type out the characters in Word. Tap the character A in 1 second since the pointer is initially on A. So here it's like, okay, initially on A. So is it cheaper to go clockwise or counterclockwise? Do that. So we're on A. Okay, we go to A. Cool. Now we go to B. From A to B, I think we always keep track of the previous word. Like here I can say let previous equals A. Is it cheaper to go clockwise or counterclockwise to B? Okay, and then previous equals B. Is it, yeah, I think we can just do this until we get to the end. I know I'm doing this last one, but I know I was trying to do this one before and I couldn't. So let's see if we can figure this out. How do I figure out the distance from either going all the way, like wrapping around completely, or going from B to Z? So it's almost like a matter of saying, do I want to go from 1 to 25, like forward, or can I go from 1 to 25 to the left? How do I figure that one out? So I want to go from A to B. Is it faster to go from, if A is 0, is it quicker to go from 0 to 1, or from 0 to 1 the other way. That's really what I'm trying to figure out. How do we figure out any forward motion should just be like forward motion is determined by 25 minus, right? Because 25 represents Z. So it'll be 25 minus the car code that we're at, right? From A to B. No, forward motion is determined from the current car code that we're at. Current car code minus the previous car code, right? Forward motion here would be the distance from B to A, or A to B, which is 1. Now the other way, if I wanted to go from A to B, right? That means I would have to go from, like, let's say we were going from, let me think of another example. Like if I was doing C, F, G or something, going through A to C would be the car code of C minus the car code of A, or it would go from C all the way to the left. Let me think about this. C to A would be that distance, or we go, that's if I'm going left. If I'm going right, it would be from C all the way to 25, all the way to Z, plus this operation, right? Yeah, it would be the distance from Z to this. Yeah, actually, I think we can do the distance. That would be 25 minus current car code plus the distance of current car code, right? Because we would need to go from C to Z and then all the way from A to C. And A to C is already calculated from this. So I think, let's see if we can try this out. Let's do let previous equals A. Okay. So for const car of word, what is it we want to figure out? We say let current equals car. Okay. Or maybe we don't even need to create a new character, right? We don't need to create a new variable because that's what car is for. So we can say current car code equals car dot car code at 0 minus 97. We're normalizing it. Let previous car code equals previous dot car code at 0 minus 97. Now we can say let forward equals, let's see, current car code minus previous car code, right? Let backwards equals, that's forward motion. The other way would be 25, since that represents Z, minus previous car code. And I think here we can just do plus forward. And minimum type, let's say let min equals 0. Here we can say min plus or equals math.min of, let's see, min or math.min of forward or backwards. And then we'll also need to make sure that the new previous now becomes car. Return min. I'm thinking we can do this, and I'll explain it a little better once I'm done here. So we have car, and previous needs to start. Let previous equals A. That's where we start. Current car code is car code at 0 minus 97. Previous car code is previous dot car code. We can either do like current car code minus previous car code, or we do the distance of 25 minus current car code. Yeah, this should be current car code plus current car code minus previous car code, which is just forward. Then we do the minimum. Let's also get the minimum. The minimum will be the min of the current min or the min of forward and backwards. And then we set previous equals to car to do the next round. So let's see what this returns. 0 and 5. Am I not adding every single time? Min plus or equals math.min of min or math.min of forward and backwards. Very curious why that. Maybe I'm doing some math here incorrectly. Let's see. So are we always, maybe we're always going to pick. Maybe it shouldn't be, yeah, no, we should, this shouldn't be this, right? I don't know why we're doing min. We should always just be adding the minimum. It doesn't need to be a comparison per se. We should just always add the minimum of these two calculations. Okay, so math.min of forward or backwards, 2 and 5. So how am I thinking about this? I guess we're gonna go for the hour this time because I'm actually having a good time here. So the way that I'm thinking about this is we have an array. I'm just gonna draw all this out. Or can I, let me see. Alphabet generator. I think there's a nice website that does this for me. Not this one. I guess number of letters. I want 26, but they don't have like the alphabet. Probably by the time that I get, oh, here we go. Yep, this is a nice one here. And let's do it separated by this. Yep, beautiful. Okay, so let's say we have this to start off. We have this text array, ABC. So in the beginning, we start at A, but now we're going to C. So we can either go like from A to C, which would be 2 minus 0. So that's going to be 2. Or they're saying that we can go from A. Oh, we can go from A through C, which will be this one. So let's compare that. It should be current minus the previous, which I believe is the forward. Current minus previous. I see. Or the backwards would be, like if I'm now going from C to F, I can go forward, so F minus C, that distance, or I go from C, or I can just do this distance, which is just 2, right? So it could be current car code. Maybe this is the piece. This should actually be current car code plus the distance of, oh, I'm kind of everywhere. Okay, so current car code plus the distance of 25, which is Z, minus F. So I think that's what it is. And maybe this shouldn't be previous. This should be previous car code plus 25 minus current car code. Maybe it's this. Right, so let's look at that again. Let's say I want to go from C to F. I can do, let's see, 0, 1, 2, 3, 4, 5. I can either go 5 minus 2, which is 3 forward, or I can do from C to A, which is a distance of 2, plus the distance of 25 minus 5, which is 20, right? Because I have to go all the way down to here. Give me 1 second, let me check something. Nice. All right, so let's try that one out. See how that looks. Still get a 2 and a 5. And they always want the minimum, right? A character can only be typed if the pointer is pointing to that character. Now, what does that mean? Given a string word, return the minimum number of seconds to type out the characters in Word. So move the pointer clockwise to B in 1 second, right? Because we go A to B. All right, type the character B in 1 second. Oh, I see. So we move it and then we type. Maybe that's the part that I was missing. 5 and 5. Let's see this. I think I was missing the +1 for the actual typing. 5, -20, and -19. Oh, you know what? This, let's see, previous car code plus 25 minus current car code. Current car code should not be, why would this be a negative number? Current car code minus previous car code. So maybe these should be absolute distances, because from Z to B, maybe from A to Z. Oh, interesting. If it's A to Z, I think here what we're missing, let's see, probably need to use some modulo operation here, right? For each one of these, should we do a modulo? Kind of just, not really, I don't want to say I'm guessing at this point, but I am sort of trying things out here. Maybe it needs to be modulo 25 since everything is normalized to 25. Let's see this. Yeah, because we need to take that into account. 5, 5, and negative 19. Okay, couple of things we're missing here. I know we're really close. Let's think about that a little more clearly, okay? B to Z to A. B, Z, A. So if we have here B, Z, A, I can either go from A to B, so that's 1. Okay, then when I go from B to Z, I can do Z minus B, or I can do B minus the A, okay, and then plus Z to B. That's fine. Then when I get here, how do I go from 26 to 0? I shouldn't do, that should be 1, right? From 25 to 0 should be 1, but what I'm going to be doing, that's going to be a negative number. So how would we, I think if we do 0 minus 25, maybe we get the absolute value of that, and then we do a modulo, and maybe we do a modulo of 25. So maybe this should be the absolute value, modulo 25, okay? And then if we do it the other way, should we also do absolute value here? Math.abs of previous, okay, we do all this piece, modulo 25. Let's try this one out. 5, 5, and 7, 5, 5, and 39, getting a little bit closer, but not quite. So let's see, that next one should be a 7. So let's see where we went wrong here. We go from A to B, that's going to be closer, or we can go from A all the way to the other side, okay? So that's 1, that's going to be 2 in the beginning. If I go from B to Z, that'll be 25 minus 1, that's 24. Or I can go from B to A, so that's 1, right? And then, oh, and that's the thing, I'm adding. If I go from B to Z, why is it that I'm adding all the way from, maybe here. Here I don't need to be, let's think about this. And then the distance of 25 minus the current one, which is actually 0, so that should just give me 1 anyway. Yeah, that should be another 2, so that's fine. That's what I'm doing, right? 25 minus current car code. Yeah, 25 minus Z, so previous car code, which is B. If I want to go from B to Z, I can go forward. If I want to go back, I'll do B plus 25 minus current, which is 0. So 1 modulo 25. Let's see, maybe this needs to be, okay, 1 modulo 25. That should be another 2. So that's good. Let me see this last piece. Okay, so that should give us a 4. And now from Z to A, that could be 1. Interesting. So we should be getting 7. Move the pointer clockwise to B in 1 second, tapped character B. Move the pointer counterclockwise to Z in 2 seconds. So it shouldn't be, should this be 26 then? I feel like I'm off by 1 number. Maybe it might be one of these. Previous car code is 1. That's the B plus 25 minus current car code. 25 minus 25 is 0. So it's 1 plus. But maybe I'm not factoring in the distance. I think there's an easier way of doing this, but because we're nearing the hour, I know we're so close to finishing this, and I really should figure it out. I'm gonna have to figure it out. I've already said twice that maybe I can end it, but I'll feel terrible because this is 1 and 2 because we are going from 1 to 26. How can I represent that using a modulo? Because we're going 2 to the left. If I go out of bounds, do I just start at 26? Let me do something real quick. I gotta put my AC on because it's really hot in here. I live in South Florida, guys. Something so simple. 1 and 2, and I go to the left. It's literally just a modulo, but I'm trying to remember how would I do that? I mean, can we do 1 minus 26 modulo 26? Is that even, or 1 minus 25 modulo 26. 1 minus 25 is negative 24. 24 modulo 26 is 24, but it's the difference, or 26 modulo 24 is 2. So is that how we do it? I can go forward, always be that, or to the left, will it just be the length? Modulo, well, 26 modulo 1 is that, 26 modulo 2, but then 26, because we did what? We did 1 minus 25. So would it, maybe it's just that? Let's see. Let's put this on the right. Let's get this one back on the left. Maybe backwards is actually a different calculation. Maybe it should be the current car code. This 1 minus 25. Previous car code minus 25. And why are we doing minus 25? Maybe it doesn't need to be minus 25. What if it was like to y? So if it was 1 modulo minus 24, wait, 1 minus 24, 23 modulo 26. Or 26 modulo 23 is 3. So is it that? Let me move this over a little bit more. Move this over a little bit more. I just want to have this like this. So do we just do, let's see, math.abs of previous car code minus current car code. And then is it just 26 modulo this? Now, why is this one not 26? It's weird that this one's 26 and this one's 25. Maybe we should also make this one 26. And 6 and 17, so we're even more off than we were before. How do we have nan here? Math.abs of current car code minus previous car code modulo 25. Okay, and then 26 modulo math.abs of previous car code minus current car code. Do I have any like misspellings here? How is that first one not a number? But we still got 5 and 7, so we're even detracting further. Okay, well, we tried again. This is the point of the weekly roundup. Some questions go really well, others don't go as well. I thought we started off really strong, and perhaps maybe I should have just kept it at that. I probably will stick more to my rules next time. But you know, sometimes you get excited, you do a little more. So with that being said, hope you all enjoyed this week's weekly roundup. We'll be resuming tomorrow with a normal LeetCode Live, where we'll continue pushing the amount of questions that we do to get to our next big milestone of 300 questions. So really happy that you all joined. I'm glad to have you all here. Looking forward to speaking with you all more next week. for any people in America, hope you all enjoy your Labor Day tomorrow, and I'll be seeing you all real soon. Happy coding.